on to the next speaker. So it's a pleasure to introduce Professor Lovegrove. She's Professor of Human Nutrition, Director of Claire Unit of Human Nutrition, and Deputy Director of Institute of Cardiovascular Research. It's a mouthful. University of London in England, and I'm collaborating with her here at the affiliated with the University of London. We on the PhD of getting food together with the influence. And I don't think you need a lot of information really on topics of diet and dairy fat, and really looking forward.
Thank you very much, Sabita. Thank you very much, Sabita, and thank you very much to the organisers for inviting me here to talk. Beautiful place. It's really a delight to be here. So I'm going to talk about the impact of dairy foods, as we all have, but particularly looking at cardiometabolic risk. And I'm also going to talk about fats in a slightly different way to Benoit talked about. So I don't need to tell this audience that cardiovascular diseases are the greatest killer worldwide. And when I started my career many years ago, we thought of it as a Western disease. But you can see here from this graph where the dark red is the highest incidence of ischemic heart disease, is moving over to the east. Having said that, it's still a problem in the West. And in the UK, it's been estimated that every 8 minutes, someone dies in coronary heart disease. And that's a shocking statistic. In addition to this, there's real inequality or health inequality in relation to cardiovascular disease. And in the UK, in those living in deprived areas, they have 4 times more likelihood of dying from premature heart disease than those living in the least deprived areas. So it's a real big problem, and this is not just a UK problem. Of course, worldwide, we have a number of different recommendations, and I've just put up here the new Nordic nutrition recommendations that were published in 2023, very food-based, really accessible, and then our Eat Well guide here in the UK. And really, one of the key points or key recommendations in relation to cardiovascular risk is the reduction in saturated fats. However, this has been questioned, and these are just some headlines, as Benoit showed, a few headlines that are questioning this. This was taken from about 10 years ago, and there were some very high impact papers that drew a lot of media attention that seemed to challenge whether saturated fat is really, or its reduction is really required. And so the scientific community responded to this, and I have the privilege of being a deputy chair of the Scientific Advisory Committee of Nutrition, a UK government advisory group, and also sat on the Saturated Fat and Health Working Group. And we looked at all of the totality of the evidence and were convinced that there was still a requirement to reduce our saturated fat to no more than 10%. And we added to our guidance by saying we should replace that by unsaturated fats. And this was also, to a greater or lesser extent, mirrored all around the world. We have this lower saturated fat guidance. However, disappointingly, when we look at the dietary intake data, this is taken from the latest UK National Diet Nutrition Survey in the UK, we're unfortunately not complying with it. And over 3/4 of our population are exceeding the recommendations, with children about 90% exceeding that saturated fat recommendation. So we need to really identify where our saturated fat's coming from in our diet. We don't eat saturated fat. We don't eat ascorbic acid. We eat foods, we eat diets. And it's really important to look at our diet to identify ways in which we can actually reduce this saturated fat. This is UK data, but very similar to the Canadian data shown and around Europe. This is the greatest contributor to saturated fat in our diet. The greatest contributor in the UK diet, which is about 30% of our saturated fat intake, is dairy products. A close second is that of meat. So animal foods is a great contributor to saturated fats. So therefore, it would seem prudent to either eliminate or certainly reduce our dairy products in our diet. And we were really interested in this. So we did some work. On a previous PhD student of mine, Sarah Gaio, did this meta-analysis, systematic review. As shown by many in this symposium, there was no beneficial or detrimental effect of milk, and this is per portion, on cardiovascular disease risk. She looked at other different types of foods And she actually found that for every 20 grams per day of fermented dairy, and again, yogurt and cheese, were associated with a small but significant reduction in cardiovascular disease risk. And this is for 20 grams. And of course, a portion, say, of yogurt's probably about 120 to 150 grams. So it's coming into seemingly benefit in relation to fermented dairy foods. But as we've been challenged, Benoit said, you know, what do we do if we're going to reduce dairy? What happens if we substitute it? And what is the benefits of this? And what we were interested to look at is, does the foods that deliver the saturated fats in our diet make a difference to our risk? And this is some data from Kim, sitting in the audience, Schmidt, who myself and Sabita and Ian supervise. So thank you for letting me show this data, Kim. What Kim did is looked at the impact of substituting 2.5% of total energy from saturated fat from two different sources. So in this particular analysis, she looked at total meat substituted by total dairy. And you can see from this analysis, she used the EPIC Norfolk study, which included almost 22,000 males and females with a long follow-up of about 25 years. And this analysis showed that if you substitute meat saturated fat with dairy saturated fat, you get a reduction in risk of cardiovascular diseases, no impact on stroke in this particular analysis. So that means there's probably other components within that food that may either attenuate the risk or increase the risk of cardiovascular disease. Kim presented this data yesterday very eloquently, and I just want to show one of her slides here. So this is some data she went on to look at using a very large cohort from the UK Biobank. So it's an up-to-date cohort. There's over 120,000 males and females with a shorter follow-up of about 8 years. And what Kim was looking at here is, again, substituting 2.5% total energy from saturated fats from different meat sources with that, and I'm showing here of yogurt, but this is very similar data to cheese, so the fermented products. And what Kim found here is that if you substitute all unprocessed meat, unprocessed or processed red meat, but particularly at the bottom here, processed poultry, in fact, my pointer's not working, you can see there was a beneficial reduction in risk of cardiovascular disease. We were really interested in the poultry side because it's complete opposite to the unprocessed poultry here. So these are things like chicken nuggets and breaded chicken. So you can see that different foods do deliver different risks, even though they might have similar amounts of saturated fat in them. So we're interested in this. We've said, many of us in session, it's a complex food, it's a nutrient-dense food, and it contains not only fat, and in fact, in semi-skim fat milk that we consume the high quantity in the UK, it's only 1.7% fat. But it also contains all of these other nutrients, different types of proteins and peptides, micronutrients, and other probiotics if you're thinking of fermented foods and so on. So a previous PhD student of mine, Aggie, did some systematic reviews and meta-analysis, looking particularly at the bioactive peptides. And this is just an example of one, which are lactotripeptides, which are casein-derived tripeptides. And this analysis looks at those supplements and how this may impact on the greatest contributor to cardiovascular disease, that of blood pressure, and also, of course, a very important risk factor for type 2 diabetes. And what she found in this analysis was, in fact, there was a significant reduction of about average of about 4 millimeters of mercury in those that took these supplements compared with those that didn't. So this clinically on a population level is very important. So these bioactive peptides seem to reduce blood pressure. She then went on to do a human intervention study, and this is the results from the chronic study. She also did an acute study. And what she wanted to look at here is, what is the difference between the different types of milk protein? So that's whey and casein, and she used casein and calcium caseinate in this particular study, and she compared it with maltodextrin, a carbohydrate control. She gave these men and women that were slightly or mildly hypertensive these products, a high amount, 58 grams, 56 grams a day for a 12-week, 8-week period with a 4-week washout in a double-blind study. I'm just going to show you the results for the blood pressure. This is central blood pressure here. If you look at the whey protein here at the end in green, you can see there's a significant reduction in both systolic and diastolic blood pressure after an 8-week period of consuming the whey protein. There was no impact of the maltodextrin or the casein. So obviously some proteins within the whey protein seemed to have a beneficial effect on blood pressure. And this was the same for peripheral blood pressure measures. She also looked at postprandial effects, and there was a significant reduction in postprandial blood pressure as well. So there has been proposed mechanisms by which bioactive peptides or milk peptides can impact on blood pressure. And this is one of the most common mechanisms, proposed mechanisms. I'm sorry about the blurriness of this slide. But basically, it's on the angiotensin system. So angiotensinogen is produced by the liver and is converted to angiotensin 1 by renin that's derived from the kidney. And this then goes down to angiotensin 2 with the angiotensin converting enzyme here called ACE. And this increases blood pressure by forming vasoconstriction. So if you can block ACE or angiotensin converting enzyme and reduce the conversion to angiotensin 2, then you might be able to reduce blood pressure. And this is exactly the mechanism which has been proposed for dairy. And I'm not showing you the data today, but Aggie did some work looking at in vitro pre-digestion of the whey and the casein, and found actually the permeate, which is that would have been absorbed, actually had angiotensin enzyme inhibitory factors and also a lower angiotensin enzyme activity within her subjects that took whey. So this seems like a proposed mechanism and one that seems to be affecting blood pressure in these people. So there are no essential foods in the diet. However, dairy is a nutrient-dense food, and it is quite helpful, particularly in children. This is analysis that Dieter Hobbs did in my group, looking at the UK and looking at the contribution of dairy to nutrient intake. It's a low-energy food generally, but what we found was it gave about 50% of our reference nutrient intakes of a number of minerals, and also vitamins, calcium, phosphorus, iodine, riboflavin, and contributed within our population on average about 100% of our reference nutrient intake for vitamin B12, which is found only in animal products. So it's a helpful food and nutrient dense. Therefore, and also following on from what Benoit said, we wanted to try and develop dairy foods that weren't necessarily low in fat, but that had a better fatty acid profile. And the evidence is very strong that if you replace saturated fat with unsaturated fat, it reduces LDL cholesterol and has other beneficial effects. So rather than skimming the fat off, which re-enters the food system, as was been said previously, what we wanted to do is to change the fat profile by using a food chain approach. So we did this in our farm in the University of Reading, and we fed our cows a high oleic sunflower oil diet. So this is high monounsaturated fatty acids. And we fed them a kilogram per cow per day. We fed it for 4 weeks. We milked our cows, and then we measured the fatty acid profile of that milk. And you can see here from this that the blue here, green is control, and the grey is our modified milk. There was a significant reduction in saturated fats in that milk and a significant increase in MUFAs. But that was both cis MUFAs, which are beneficial, but also trans MUFAs, which are not believed to be beneficial. So we wanted to go on to see, okay, we've developed this food. Does it have any benefits to the human? So we produced ultra high processed, ultra treated milk, hard cheese, cheddar cheese, common in the UK, and also butter from our dairy. And we fed this to a group of men and women that were slightly elevated risk of cardiovascular disease. We gave them a high fat diet, 38% fat. UK intake is about 35% now, so higher than our average intake, high dairy diet. We want to look at the impact of this on a number of risk factors. So I'm just going to show you some of the factors that we found. First of all, starting on lipids. So what we found was feeding these modified dairy, or feeding the control conventional dairy, significantly increased total and LDL cholesterol, with a low density lipoprotein, LDL cholesterol being the most atherogenic lipoprotein. But after the modified dairy, you can see that attenuated that increase. So it had beneficial impact on the profile of our lipids. We also are interested in looking at the health of our blood vessels. And we did this by measuring flow-mediated dilatation, looking at the dilation of our blood vessels. It's a clinically relevant measure, and high levels are beneficial. And what we found is that our control dairy, our conventional dairy, reduced FMD, but in fact, our modified dairy increased it. So we had developed a milk that had high fat, but it had a better modified fat profile. It had beneficial effects on both lipids and also vascular function. And we estimated that if the dairy or the milk within the UK population all was this type of milk produced by this food chain approach, it would take about 86,000 tonnes of saturated fat out of our food chain a year, and that's quite considerable. But it's all well and good having a food. We as consumers have got to eat it. So it's got to be palatable, it's got to be available to us. So we performed a number of consumer studies, and I'm just showing some of the data here. And what we found that when we compared our conventional with modified milk, we found that there was our consumers couldn't tell the difference at all. When we compared the different cheddar cheeses, they actually preferred the conventional cheddar cheese, and we think that's because of the starter culture, which made it more tasty. But we could produce our modified cheese with that starter culture. And when we looked at the butter, they actually preferred the modified butter. And the reason they gave was because it tastes the same, but actually from the fridge, it could spread because it obviously had a high amounts of unsaturated fat, so it was spreadable from the fridge. And when we told our consumers there may be some benefit from the modified dairy, they were actually increased the liking for the cheese, for example, and in the intention to purchase that. So there seemed to be, so not only was it liked, but also they would buy it. So that was really encouraging. But the Nordic recommendations, and also in the UK, we're considering the environmental impact of our diet as well. And this is some data globally showing in orange here that from the carbon dioxide emissions, about a third of it is from our food we consume. So that's a considerable amount. And of that, about 18% is from animal foods. And this is why we generally propose to have a more plant-based diet. So dairy has a bad reputation. It does produce a lot of carbon dioxide emissions, mainly through methane, through the animal burping. But what we found in our studies, in our study we call the RESET study, but also other studies, this is some old data, that as we increase the lipid supplements in our cows here, the methane produced was actually reduced in a linear fashion. So this milk not only seemed to be healthful, had benefits to the human and would be eaten and liked by people, it also had a better environmental impact. And it's also important to make sure it's accessible to the general public. And we were delighted when a supermarket called Marks and Spencer's, I don't know if you have heard of that in Sweden, but it's a high-end supermarket. And they changed all of their milk to the milk produced by our food chain approach. And they estimated there was about 3 million shoppers every year that were consuming this milk, and the price point was identical, so it cost the same. So we were delighted to show that it was actually accessible to the general public as well. So just in conclusion, I'd like to say that the priority to provide sustainable, healthful foods for the reduction of cardiometabolic risk is a real priority to us as nutrition scientists, I think, and to the science community. We've shown dairy foods are nutrient rich. They're not essential, but they are good food, and the majority contribute to the most saturated fat in our diet. However, the associations between milk seems to be neutral, and some of the fermented dairies actually may have a benefit. And that it's important that we look at the way in which we advise people to reduce their saturated fat, and that possibly changing the fatty acid profile of dairies may be one strategy to use with our reduction in saturated fat within our diet. So before I finish, I'd just like to thank the whole of the research group within the Hugh Sinclair unit of human nutrition, Kim, of course, for allowing me to use her data, and thank you very much for your attention.
Thank you, Judy, for a wonderful talk.